Hello and welcome to the next lecture video in Theory of Computation. Let's see one more example of DFA. Type 9. Construct a DFA that accepts set of all strings whose nth last symbol is some specified symbol. For example, DFA for the strings whose second last symbol is A, where alphabet sigma equals to A, B. Here, the set of strings that belongs to this language must be of length 2 or more. Therefore, the basic string that belongs to this language must be of length 2 and are A, B or A. Since the second last symbol of this string is A, similarly the second last symbol of this string is also A. To construct the DFA for this language, we first represent these two basic strings by using a state diagram. So let's start with the starting state Q0. Reading the symbol A from Q0 state leads to the state Q1, and then reading the symbol P in Q1 state leads to the state Q2. Since this basic string belongs to this language and hence should be accepted, therefore we make Q2 as a accepting state. Similarly, for this basic string, reading of first A symbol in Q0 state leads to the state Q1, which is already present there. Then reading the second A symbol in Q1 state leads to the next state Q3. Since this basic string also belongs to this language, therefore we make this Q3 state as accepting state. Here, reaching to the Q2 states indicates that the last two symbols of that string are A, B. Similarly, reaching to the state Q3 indicates that the last two symbols of that strings are AA. Now, what if the machine reads the symbol A in Q2 state? That means reading A after this AB. In that case, we have to further check whether one more symbol, that is either A or B, is present after this A or not. So this checking of further symbol is performed by using either this transition or from this transition. Therefore, reading this A symbol in Q2 state leads to the state Q1. Similarly, what if the machine reads a symbol B in Q2 state? That means B after this AB. In that case, we have to further check whether AB or AA is present after this B or not. This checking of AB or AA is performed from the initial state Q0. Therefore, we switch to the state Q0 on encountering the symbol B in Q2 state. Similarly, what if the machine reads the symbol A in Q3 state? That means A after these two A's. In that case, the second last symbol A is already present there. Therefore, this string should be accepted, and how many A comes after this A's should also be accepted, and hence we make this transition on encountering the symbol A in Q3 state. Similarly, what if the machine reads the symbol B in Q3 state? That means B after these two A's. In this case, the second last symbol is A and the last two symbols are AB, therefore should be accepted by the state Q2. Therefore, we make a transition from Q3 state to Q2 state on encountering the symbol B. Finally, what if the machine reads the symbol B in Q0 states? That means it reads B as a starting symbol. In that case, we have to further check whether AA or AB is present after this B or not. So this checking is performed from the initial state Q0. Therefore, we'll just make this transition on encountering the symbol B in Q0 state. As we see, we define all the possible transitions. Therefore, this is our final required DFA. Now you can try yourself to construct a DFA that accepts set of all strings whose third last symbol is A in similar fashion. That's all in this lecture video. If you have any queries, then please leave the comment, and thank you for watching this video.